Okay, so once the NMR has finished my experiments, I'm automatically going to receive an email that contains my data. This podcast is going to show you how to extract that data from your email and open it in TopSpin, which is our NMR software. I'm also going to show you how to do basic processing of your spectrum. So when I open my email, I see that I have a series of messages from felix@gustavus.edu. These are automated messages sent from the NMR. If I click on this message here and save the file, I prefer to save these to the desktop so that they're easy to find later. And here it is, the zip file. You'll notice that it comes in a zip format, so it actually needs to be extracted before it can be opened in TopSpin. So I'm going to right click and choose Extract All and click Extract here. Okay, so now I have usable data. And you can also see that another file appeared below the zip on my desktop. The next thing we need to do is open TopSpin, so I'm going to search for it in the search bar. Open the application. Okay, so this is TopSpin. And the next thing I need to do is import the data into TopSpin. So if I double click on this title, which is cumin, I'll get to the actual experiment number. And I can actually just drag this file straight into TopSpin. You'll notice that it says no processed data available, and that's because we haven't actually processed the spectrum yet. But if we click on this FID tab, we'll see the free induction decay pattern, which is the raw, unprocessed form of your data. In order to change this FID into a readable spectrum, I'm going to use the Process Spectrum tab, which is under Process here, and then I click Process Spectrum. And this is actually going to perform 3 separate commands at once. And you'll see that now this looks more like what you're probably used to an NMR spectrum looking like. And I'm going to quickly walk through what the 3 steps are that the Process Spectrum button will do to your spectrum. So if I go back to the FID, you'll see that the typical shape of an FID is kind of this tapered arc. And a lot of these points out here, these small little data points, are actually noise. They're not true signals from your sample. So in order to improve the signal-to-noise ratio, we can perform what's called exponential multiplication, which is a mathematical function that will truncate the data and improve your signal-to-noise ratio. So if I click on this down arrow under Process Spectrum and click Window Multiplication, this is already set up to do exponential multiplication. So I'll just click OK, and you can see that a lot of these points that were out here are now gone. It's important to know that although this process is important and it does improve the signal-to-noise ratio, it actually does also decrease the resolution of your spectrum a little bit. So it's just important to know that trade-off. The second thing that happens when we click the Process Spectrum button is a Fourier transform. You'll notice that an FID is in a time domain with the x-axis in seconds. And a typical NMR spectrum that we're used to processing has an x-axis in frequency with units of either hertz or ppm. So there's a mathematical function that actually converts time domains into frequency domains. So if we just arrow down to Fourier transform and click that, you'll see that we now have an x-axis in ppm. And the last thing that happens when we click the Process Spectrum tab is an automatic phase adjustment. So if we click on Adjust Phase, this down arrow, and go to Automatic Phasing Options and choose 0th and first order correction, this is the automatic phasing of our spectrum. And it looks pretty good in this case, but there will also be some times when the phasing doesn't work well automatically and you'll need to manually adjust the phasing of your spectrum. And manual phasing will be demonstrated in another video.